Okay, so section 6.7 is on graphing and solving quadratic inequalities. So remember, quadratic equations are parabolas. Quadratic inequalities are going to involve the less than, greater than, all of those signs. So it's going to involve shading. So just like you did with lines, now we're going to have parabolas with shading. All right, so a quadratic inequality in two variables is an inequality that can be written in one of the following forms. So you can shortcut this if you want, and you can write y and then do ax squared plus bx plus c, and then we'll just put a little box here. Okay, in that box, you could have four different signs. So you could have less than, greater than, less than or equal to, or greater than or equal to. So we kind of shortcutted it. We didn't write out all four of those equations or inequalities. Okay, a, b, and c are real numbers, and a is not equal to 0. If a was equal to 0, then that would just be a line, right? There'd be no x squared term. All right, so number 1 says y is greater than x squared minus 3x plus 2. Okay, so our boundary curve is if we just had y equals x squared minus 3x plus 2. Is it solid or dotted? Dotted, because it's just greater than, right? All right, and we know how to graph a parabola. There's lots of different things we can do. The first thing that's going to be useful is finding the vertex. So then we will be able to find that axis of symmetry. So if I'm finding the axis of symmetry, I have x equals negative b over 2a. So I get negative 3 over 2 times 1. So I get 3 over 2. So 1.5. So directly between the 1 and the 2. All right, and if we want to know how low that goes, we can plug it into the y equals. So I have y equals 3 over 2 squared minus 3 times 3 over 2 plus 2. So I get 9 over 4 minus 9 over 2 plus 2. So what is that? Is it negative 1/4? No. Let's see. So 9 over 4. Let me get common denominators. Minus 18 over 4 plus 8 over 4. So negative 1/4. Yeah, I was right. So my vertex is 3 over 2 comma negative 1/4. So it's right down there. Is my parabola going to go up or down? These aren't hard questions. You guys are just tired. Long week. It's going to go up, yeah. It's going to go up because it was a positive x squared. And other points that are useful to find are the x-intercepts. You find that when you plug in 0 for y. So you'd have 0 equals x squared minus 3x plus 2, and you can factor that. So I get x minus 2 and x minus 1. So I get x equals 2 and x equals 1. So at 2 and 1, I'm going to have points crossing the axis. Kind of hard to see. And then another point that would be useful is to find the y-intercept. Y-intercept, you plug in 0 for x, so your y-intercept is 2. Okay, I'm kind of running you through a lot of steps that you're going to have on your test. On your test, you're going to have to graph a couple of these parabolas, and you're going to have to go through all those different steps. So you'll find the axis, you'll find the vertex, you'll find the x-intercepts, the y-intercepts, any other points if you need them, and then you'll graph. Okay. All right, so our parabola is dotted, and it goes through all of those points. It's 3 over 2 comma negative 1/4. So 1.5 comma negative 0.25. So it's real little. All right, and the last thing is the shading. If you want to know where it's shaded, just like before, you can check a point that's not on the curve. So 0, 0 looks kind of close to the curve. I mean, if you know for sure it's not on there, I know for sure it's not on there. Do you guys know for sure it's not? The way I drew mine, it kind of looks like it is. But basically that point, you already had 1, 0, so you're not going to have 0, 0 as well. So if you want to check 0, 0, you can. If 0, 0 is on your curve, just pick any other point. So if I check it in my original, I'd have 0 is greater than 0 squared minus 3 times 0 plus 2. So 0 is greater than 2. That's false. 0 is not greater than 2. So that means that 0, 0 is not in the shaded region. So we're going to shade above the parabola, so in the inside part. If 0, 0 made it true, you would shade all of this area. Okay. All right, makes sense? Not too hard. Okay. So it says in order to solve quadratic inequalities, so if we had just an x, no y value, you first need to find what we call critical numbers. Okay, this is really important in later math classes, especially calculus. If you guys go on to take calculus, we do this constantly. These are the values that would make the right side equal to the left side with no inequality sign. We can find these critical values in many different ways. You can try to factor, you can use the quadratic formula, complete the square. You're basically just solving a quadratic equation. Factoring does not always work though. For instance, you might have an answer with a square root. So if you had square root of 2 for one of your critical numbers, you can't find that by factoring. Okay, so steps to solving quadratic inequalities. So first find the critical values by using an equation, not an inequality. All the ones that I'm going to give you, you'll be able to factor. So factoring will always work in Algebra 2. Number 2, plot these critical values on a number line. 3, check test points in each interval. So like on the left of those points, in the middle of the points, on the right of the points. And then 4, which points make your original inequality true? So number 1, so I want it to be equal to 0. I want to treat it just like an equation. So I'm going to write x squared minus 10x plus 18 equals negative 3. So I'm going to use an equal sign instead of the inequality sign. I'm going to add the 3 over. So I have x squared minus 10x plus 21 equals 0. And then I said in Algebra 2, I'm always going to have ones that factor for you guys. So you should be able to factor these. If you can't, you can always try quadratic formula. So I have x minus 7 and x minus 3. So that way my last numbers multiply to be positive 21, my outer and inner combine to be negative 10. Okay, we set each piece equal to 0. So I get x equals 7 and x equals 3. These are what I call my critical points. Okay, we put them on a number line. So put them in the order that they go in. So 3 comes first and then 7 is after it. And I only put those numbers on there. I don't put a 0 on there or anything because that gets confusing. All right, then we're going to test a point on the left of 3, a point in the middle of 3 and 7, and a point on the right of 7. Okay, I usually put them in a little table. And see in your original, if I look at my original and I look at this new one, the inequality that I have is x minus 7 times x minus 3 has to be less than or equal to 0. See, all I did is I added the 3 over and then factored. So let's think about what that inequality sign would have been. So if I have all of that stuff is less than or equal to 0, what are numbers that are less than or equal to 0? What do we call those numbers? Negative numbers. All right, so we want our answer to be a negative number. Does that make sense? Okay, so when it says less than or equal to 0, that means we want negatives. Okay, so I'm going to check numbers on the left, in the middle, and the right. So I'm going to try 2, 4, and 8. So 2 is on the left of 3, 4 is in between the two numbers, 8 is on the right. And I'm going to check them in the factored form. So x minus 7 and x minus 3. And you're not really worried about what the end number is. I mean, you can figure it out. Like if you plug in 2, you get 2 minus 7 is negative 5. 2 minus 3 is negative 1. So negative 5 times negative 1 would be positive 5. So we know to be positive number. So it would not satisfy this inequality because it would be greater than or equal to 0. All right, but really on these, you don't even need to find what that number is. You just need to determine if it's positive or if it's negative. So all I'm doing is when I plug in -2, I'm saying 2 minus 7 is negative, 2 minus 3 is negative. A negative times a negative gives me a positive. See how that works? Okay, now try 4. So 4 minus 7 is negative. 4 minus 3 is positive. Negative times positive is negative. 8, plug in 8 into each piece, positive and positive. Positive times positive is positive. We wanted when it was negative, so 4 is the only location. So any number that I would have picked between 3 and 7 would work. Okay, so that's my shaded. And then you need to think about the endpoints. 3 made it equal to 0, and 7 made it equal to 0, right? If I plugged in 7 or 3 in here. And we said it could be less than or equal to 0, so we fill those in. Because they made it true, they made them equal to 0. So your final answer is bracket 3 to 7, bracket. Okay. Kind of makes sense? We'll do a lot more, but it's a lot. It's like the table and the number lines. Oh man, of course my things are missing. Are they red on your, are there boxes on yours? Okay, let me find out some good ones. All right, so let's make this first one. So x squared plus 8x is greater than 9. So write that in. So x squared plus 8x is greater than 9. And make the third one negative 3x squared minus 6x plus 9 is greater than or equal to 0. All right, so first step, I want to get them set equal to 0. You can use the equal sign or the inequality sign. It doesn't really matter. Just know that what you're really finding is when they're equal to 0. You're finding those critical points. So if you want to leave the inequality sign as you're doing the problem, it's fine. Okay, so I get x minus 1 and x plus 9. So that way the outer and inner combine to be positive 8x. So when I set each piece equal to 0 to find the critical points, I get x equals 1 and x equals negative 9.
Why did you change it to an equal sign?
You basically are at this point. So if you, what I was saying is if you wanted to just leave it as an inequality sign, that's fine. Just know that you're finding when it's equal for your critical values. All right, so those are the numbers that we put on our number line. So negative 9 would come first and 1 would come afterwards. Okay, in your chart, you want to pick a number on the left of negative 9, so like negative 10. In the middle of the two things, so what's a number that's easy in the middle of them? 0. A number on the right, so like 2. So I'd have x minus 1 times x plus 9, and I want it to be greater than 0. So that's kind of the convenience of leaving that inequality sign in there, so you can see that you want it to be greater than 0. So what numbers are greater than 0? Positive numbers, right? That's what we want. We want positives. Okay, so when I try these in my chart, if I try negative 10, I have negative 10 minus 1, that's a negative number. Negative 10 plus 9 is negative. Negative times negative is positive. If I check 0, I have 0 minus 1 is negative, 0 plus 9 is positive, negative times positive is negative. If I try 2, I have 2 minus 1 is positive, 2 plus 9 is positive, positive times positive is positive. This time we wanted the positive numbers. So these are the ones that had an outcome of plus. So anything that I would have picked on the left of negative 9 would work. Anything that I would have picked on the right of 1 would have worked. And then we think about the endpoints. We wanted when they were greater than 0, not greater than or equal to 0. Those are the points that made them equal to 0, those endpoints. So we don't want to include those in our final answer. So your answer is negative infinity to negative 9, parenthesis, because we don't want to include it, union 1 to infinity, parenthesis. And that's it. Okay, next one. When I look at this one, the negative 3 is kind of throwing me off, so what can we do? Yeah, you can divide it out if you want. When you say divide it, though, if you divide it to both sides, you'd have to flip your sign if you do that. What I'll usually do is I'll just pull it to the front. So it's like a GCF, so pull out the GCF of negative 3. So I have negative 3 on the outside. I'd be left with x squared plus 2x minus 3. Factor further. So I have x minus 1 and x plus 3. That way the outer and inner combine to be positive 2x. Okay. So that means my critical points are x equals 1. Do you guys see it without writing out x minus 1 equals 0? And x equals negative 3. Those are the numbers that I put on my number line. So negative 3 comes first, and then 1 would come after. Okay, when you make your chart, you also have that negative 3. So you have negative 3 times x minus 1 times x plus 3. And we want it to be greater than or equal to 0. So we want positive numbers. Now, if you had done what Taylor suggested, and at the beginning, if you had divided by a negative 3 on both sides, remember you have inequalities, so you would have had to flip your sign. So then you'd really be looking for negatives, and it would end up being the same answer. What we're looking for are the positive numbers. All right, so this time I have a negative 3 out front, so I'm going to have a negative out front on each one, because that negative 3 is already negative. Okay. Number on the left of negative 3, let's try negative 4. A number in the middle, so 0. A number on the right of 1, so 2. So if I try negative 4 in this second thing, so x minus 1, I have negative 4 minus 1 is negative, and then I have negative 4 plus 3 is negative. So I have a negative times a negative times a negative, which is a negative. See why the chart helps sometimes. Lots of signs. All right, if I try 0, the negative 3 is already negative. 0 minus 1 is negative. 0 plus 3 is positive. I get a plus. If I try 2, I get negative, positive, positive. I'm going to get negative. Now, almost always in Algebra 2, these are going to alternate. So later on in calculus, they definitely won't, but almost always in Algebra 2, they will. The only reason they wouldn't is if you had like an x squared out front and then an x minus 1, if that's how things factored, but then that's an x cubed. So on these parabolas that you're going to have, they're going to alternate. So if you get the first one as negative, I probably wouldn't just write negative, positive, negative. What if you got the first one wrong? So I'd go through and I'd do all three still, just to make sure. All right, we want positives, so this is the one that was positive. So in the middle, I'm going to shade. I could have greater than or equal to 0, so equal to 0, so fill in the endpoints. So your answer is bracket negative 3 to 1. Okay, better? Making sense? Usually people like this section, not too bad. All right, the next one. So it says the monthly profit, P, of a small business that sells bicycle helmets can be modeled by the function P of x equals negative 8x squared plus 608x minus 4200, where x is the average selling price of a helmet. What range of selling prices will generate a monthly profit of at least $6,000? Okay, I gave you a hint. I said the inequality can be factored. Don't try to use the quadratic formula. You can, but you're going to have really big numbers since you had 4,200 for your C. All right, so We want a monthly profit of at least $6,000. So that means that this monthly profit, so negative 8x squared plus 608x minus 4,200, has to be greater than or equal to 6,000. So that was the profit. All right, let's subtract the 6,000 over. So I have negative 8x squared plus 608x minus 10,200. Has to be greater than or equal to 0. Are they all divisible by 8? Or were you trying that? Okay, so you can pull out a negative 8. Okay, you're going to have to be my calculator. I don't have mine on me. So if I pull out negative 8 from each piece, what's the next number? So what's 608 divided by 8? 76. So minus 76x. And what's 10,200 divided by negative 8? Or, yeah, so plus 1270? 75, okay. Is greater than or equal to 0. Okay, I can try to factor. It's kind of hard to factor. I noticed that 25 at least goes into 1275. So if I was doing like a factor tree, maybe try that first. So if I do 1275 divided by 25, what do I get? 51? Oh man, good guess. Okay, so I'm going to have minus 25 and minus 51. Do you guys see how the adder and inner combined to be negative 76 then? I totally just guessed that, so that was lucky. All right, so that means my critical points are 25 and 51. So I'm going to put those numbers on my number line. All right, try your numbers. Try like 0, 30, 52, something like that. And try them in the factored form. We want when they're greater than or equal to 0, so positive numbers, or 0. So when I try 0, the negative 8 is always going to be negative out front. So if I try 0, I have 0 minus 25 is negative. 0 minus 51 is negative, so I get a negative. If I try 30, I have the negative out front from the negative 8, positive and negative, so I get positive. And 52, the negative out front, positive, positive, so negative. We wanted the positive ones, so we wanted this. Okay, so this is a tricky question. It says, what range of selling prices? So the first selling price that's going to give me a positive outcome is 30. Or not 30, sorry, it's 25. It's right in between here. This is my solution set. Those are the numbers that are going to give me greater than or equal to 0. So when it says range of selling prices, those are all the things that are going to give me a positive profit. Okay, well, a positive profit of at least $6,000. Okay, so that's my range. So so X is a selling price, so between $25 and $51. So what do you think happens if we sell it for more than $51? So if I sell a bike helmet for $53, why would that not maximize my profit? Yeah, it costs a certain amount to make, but if it's too expensive, no one will buy it, right? And if it's not expensive enough, that's what Gabby's talking about. If it was $24, then it costs a certain amount to produce the helmet or ship it to your store or whatever. So you're now losing money because you're selling it for too cheap. Okay, so that's why there's a range of prices. All right, was that the last one?